The first thing we need to do is find the temperature of each substance when it's a solid. Let's start with neon. Here I have neon. I'm going to make sure it's a solid. I'm going to click on degrees Celsius. The temperature when neon is a solid is negative 259 degrees Celsius. You should write that here. Next, argon. The temperature when argon is a solid is negative 230 degrees Celsius. Next, oxygen. The temperature when oxygen is a solid is negative 246 degrees Celsius. I guess that explains why we never see oxygen as a solid. That's pretty cold. Last, water. Water turns into a solid at negative 127 degrees Celsius. The next question asks, what is the hottest state of matter? So let's look at water as an example. Where is it the hottest? Is it hottest when it's a solid, a liquid, or a gas? Write the answer here, and then look at water again. Where is water coldest? Is it coldest as a solid, liquid, or gas? Write that here. Next, how are the solid particles moving and arranged? Well, for their arrangement, I could choose packed tightly together, close together but not packed together, or very far apart. If I'm looking at the solids, in general, I can see that as a solid, they are packed closely together. Water is the exception, but we'll talk more about that later. So I'm going to write here, packed tightly together. Next, the movement. How do the particles move? Can they not move past each other, or can they move past each other? Well, I can see in all four substances, they can't really move past each other. They're vibrating, but they're not moving. Versus in a gas, they're moving past each other. But in a solid, they're stuck in place. So I would write they cannot move past each other. Next, volume and shape. Well, the shape doesn't change. Here it's basically a square, basically a square, basically a square. This is a weird shape, but whatever shape it is, it's not really changing. Let's look at the volume. Remember, volume is length times width times height. Again, it's not really changing. It's staying the same. So I would write volume and shape do not change. Next, what happens when you increase or decrease the temperature of a solid? We're going to start by cooling it or making it colder. We're going to see if the molecules get farther apart or closer together and faster or slower. What are you noticing? I'm noticing that they're getting a little closer together and they're moving a little slower. So that's what I would write here. Now let's heat them up. Ooh, as I heat them up, what are you noticing? Are they moving farther apart or closer together? Are they getting faster or slower? Write your answer here. Our challenge question. Set the water particles to a solid. Okay, I'm going to make them a solid. How do the water particles look different as a solid than neon, argon, and oxygen? So I'm looking here. Neon, argon, oxygen, water. I might say I noticed that here they're all much closer together and it's kind of square shape. But here they're farther apart.